Hey guys, welcome back to the shop. Thanks for being here. I appreciate it as always. Today we're going to forge a neat tool from this rather large vehicle spring. So what I'm forging today is a pistol grip chopper or cleaver. And I have not seen one of these before. Doesn't mean it hasn't been done, but I have not seen a pistol grip on a large chopping knife or cleaver like this. And I'm using a piece of spring steel, an actual spring, and it's presumably 5160. I have made multiple blades and tools from this particular spring, and so I'm confident with the heat treat we can accomplish on it. That is one of the cautionary things about reclaimed steel, is you don't know what you're working with until you've tested it, run some trials on it, so to speak, and figured out what it'll actually do for you, which I have in this case. So using reclaimed steel can be extra work if you actually want a good blade. But it's a big hunking piece of steel, so I've got to work that down. And the first thing I'm going to do is start forging the handle here. And I'm going to forge a tapered tang on this just to keep the weight down overall and the weight distributed where it needs to be or should be up in the blade. And that way I don't have to worry about trying to drill holes in the tang or something like that to minimize weight. So I'll just use the forging press to start the taper on the tang. So when it comes to pistol grips, I have seen multiple different blades, that have been made throughout history and across cultures with a pistol grip, including some rare Bowie knives. You see a few Bowie knives with pistol grips. And I don't know exactly what the original intentions or the intentions for weapons of offense or defense were specifically. I expect it has something to do with obviously the ergonomics, where it places the axis of the blade in relation to your arm or hand, and things like that. Some advantage to those things, but I can't say for sure. The reason I'm forging this with a pistol grip is because I have a couple ideas about the pistol grip in this application that I want to see if they're accurate or not. And the first one is ergonomics or comfort in use. And that's because when your wrist is straight, it is the strongest. And so if you're able to use a tool keeping your wrist straight, not only is that a greater position of strength, but it also should lead to less fatigue. And the second is an idea based kind of on the kukri design, where you have the crooked blade that can be very effective for pulling your target into the edge. And like I say, it can be very effective with certain things. It's a little bit limited in the size of what you're cutting, or how you can use it in some cases. And so perhaps the pistol grip will give us some of that power in the chop, so to speak, without sacrificing a long edge use. So we'll see what happens here. Anyway, forging out the pistol grip on the anvil went pretty well. Of course, obviously the press is nice to work down large pieces of steel like this, but even when it comes to doing some actual profile forging and stuff like that, using a hand hammer is still obviously part of the game. So kind of just eyeballing how much steel I need here. Going for, 8 to 10 inch blade. And the spring itself is about 3/8 of an inch thick, I believe. And I ended up forging the blade down to about 3/8 inch thick on the spine. But I didn't want it that tall or that deep. And so narrowing it down like this will allow me to then go back and forge my bevels, and that'll give me the width of the blade that I want. truing up the whole length of the blade here, or it's not a blade yet, just a chunk of steel, but getting a consistent width. Then I'm going to use my perpendicular half round dies and start spreading that steel out widthwise on the blade. And in hindsight, I had more material here than I really needed, but I wasn't sure exactly how heavy I wanted the blade and how wide, and some other things like that. And so going into it, I kind of wanted to leave myself a little extra material rather than end up with not enough to do what I wanted to do. So I definitely had some extra material, but I was able to get the bevel started here on the press, and then continue with the hammer. So the final dimensions on this blade is 3/8 of an inch thick spine, and right at this point it's actually a little bit thicker. So what you do when you're forging your bevels, like I'm doing right here, is if you're spreading the steel just on one side of the blade, it's necessarily going to start to create a curve in your blade, because one side is expanding and the other side's not, at least not nearly as much. And so the steel has to go somewhere. So you can see that starting to happen there. And I almost went with a more parang style blade where it kind of curved, and I don't think that would have been bad. I think that would have been kind of cool, but I wanted to stay with the original design idea that I had and execute that, see what I could see with this specific design. So I straightened it out, and part of the way I did that is by hammering along the spine to thin that down, but also spread the metal lengthwise along the spine as well. And so that's one way to achieve a straight blade throughout the bevel forging process. I'll go ahead and stamp my compass logo here, nice and deep, plenty of room for that. Just want to make sure this is nice and straight before I go forward here. I forged the edge down to, I think, maybe 5/32, maybe a little bit thinner, which was, like I say, more than enough. Like I say, I kind of started out with more material than I needed and discovered that I didn't really need as much. And I could have, cut it off and forged it out thinner, but I didn't do it that way. Just ended up removing some more material with the grinder, but it's pretty close as it is there. And at this point in the game, I wasn't sure, I really wasn't sure how much material I wanted to remove, from this point. My original intent was to do more of a saber grind, which is a flat grind that doesn't go all the way up to the spine, and leave some forged finish on there, which ended up being not what I did. I ended up doing a full flat grind, but I just ground the edge straight and left the spine and the end of the blade alone, so that's the original forge finish or dimensions on that. So here I'm just doing a rough grind, and I will say this blade was a bit of a challenge to grind, in the rough grind and the finish grind too. It's really heavy compared to almost 90% of or 99% of other blades or knives that I make, and with the pistol grip handle, it's you can't really hold that in line, with the rest of the blade. So it was a bit of a challenge, but got through it and took some material off there down to a decent rough grind. So go ahead and drill some holes for the handle bolts in this. And as you saw a minute ago, I left it in the forge to cool down slowly from about a red heat, and that's so that we could just drill the holes without a problem. So as you can see, it's working just fine here. Also, of course, nice thing about 5160, it doesn't have the high carbon content like 1080 or 1095 or whatever, so it's a little easier to keep from air hardening and stuff. So into the kiln we go, and fortunately it did fit. We'll do our normalizing cycle in our thermocycles as always, per usual. Scrape off that scale there. Wouldn't want that to insulate it or anything. So this is a really neat shot of the recoalescence in the steel. And you'll see how on the edge on the right hand side here, the thinner part of the blade, it cools down first. But now you're going to see where it appears to heat back up. And that bright band moves to the left towards the thicker part of the blade as the thicker part of the steel continues to cool. And what that is the steel, and it's sped up there. I sped it up because it takes a little longer than that. But that's actually the steel making a phase change. It's changing from austenite to pearlite, and as that crystalline structure changes, it's releasing the energy that was required to change it to austenite in the first place. So it cools down to a certain point, comes time for the phase change, it has to release that energy so it actually heats back up momentarily, which is what you're seeing, and then it releases that energy and continues to cool down. So pretty cool, but it's actually more useful to know that on the way up, on heating it on the way up, so that you know that you've attained austenite. But anyway, got the blade quenched, and as you might imagine with that thick of a blade, it was nice and straight. Temper the blade, and we're good to continue. You know, of course, with this thick of a blade, I kept it in the quenchant quite a bit longer than I typically do, just to make sure that there wasn't, residual heat that was going to over auto temper the edge. Because like I say, that's 3/8 of an inch thick, so pretty massive compared to most blades that I've ever done. So getting the finish grind here, and once again, it's kind of fiddly figuring out how to hold it nice and even. It's just kind of funny. It's heavy, and you can't really hold it like a normal knife. So it's kind of interesting, but got it done. Got it finished ground, and you can see right here I'm putting a convex bevel on the edge so that we have an edge that's worthy of a chopper, or a final profile that's worthy of a chopper. What that does is it gives us a little stronger edge right there, a little bit more material right behind the actual edge itself. The other thing that a convex edge does is it kind of serves to pop out or wedge out the chip of whatever you're chopping, because there's a little bit more width right there at the edge, without sacrificing sharpness, of course. So I'm going to go ahead and temper out the tang now that we have it hand sanded, and actually I'm going to go ahead and temper out the spine as well. Really probably not necessary with the amount of mass we have here, but I guess you could say that this thing is going to be pretty indestructible. So just kind of temper, or blue back as some people call it, the spine here, and leave our edge the appropriate hardness for its job. So there you go. Get that cleaned back up with some sandpaper and move on to the next step. It's getting close to time to chop stuff. Oh, the next step happens to be a little acid etch. Kind of darken that steel up. Kind of fits the motif, I think. All right, so now we can put some handle scales on it, and this is kind of exciting. This is actually the first time I've ever used burlap micarta, and if you're not familiar with what that is, well, micarta is actually a brand name but it's often used for, the material, whether or not it's the actual brand or not. But anyway, so micarta is layers of some kind of material, usually canvas, linen, or paper, and in this case, burlap. Layers of those materials, one of those materials in a phenolic resin, and so it's compressed, and then it's set. So it's a nice, dense, durable material, and you can have a real neat look to it, depending on what kind of material you use or it was made out of, and how you do it. So this is burlap, and it's got that real coarse grain look to it. So yeah, it's pretty cool looking. I'm excited about it. So get the handle scales all prepped here, countersunk, finish up the ends of the handle scales that are attached to the blade, since we won't be able to do that after they're on. Use some epoxy, and these are Corby bolts, 1 1/8" Corby bolts actually. That's the especially thick tang here, so you probably couldn't use a 1-inch bolt on this, but so these bolts are super strong, stainless steel. That's the only kind of Corby bolt that I use. We'll get those tightened down, and once the epoxy's all set up, ta-da, there we go, so we can get the handle shaped. In this micarta material, it sands similar to wood. Of course, you don't want to breathe the dust either. It's synthetic resins, some kind, phenolic resins, whatever. Not good to breathe, but get that shaped up here. And you'll notice this is a pistol grip, right? But the fact that the handle widens towards the end really is intentional too. That's to help your hand stay on the grip, so you don't have to be gripping the knife or the chopper as hard, because that natural widening of the handle disallows your hand from slipping off. So that's an important part of the design, in my opinion. Plus, it just adds to the overall ergonomics and comfort of the handle. So use the slack belt a little bit, get that shaped up, and then some additional hand sanding to get those nice contours on there. The ricasso area, I guess you would call it, where the finger loop is, or finger groove, get that sanded and rounded nicely. Now it's time to put an edge on it, so we'll use our itty bitty stones and put an edge on this massive chopping blade here, and a little stropping action. Again, it was not terribly easy to use these sharpening tools with this blade, but mostly got it done. There's a couple hiccups in the edge there, but took it back to the strop a couple more times, and it's definitely easy to let the blade run away with you on that paper. So let's see how this thing works. So we got a standard 2x4 here, and it definitely eats through the 2x4. So I have to say that overall I'm super pleased with it. The ergonomics part of this definitely, in my opinion, definitely came true. Being able to use a chopper like this, I was not feeling the shock. I wasn't feeling any shock transmitted up through my wrist or arm like you often do with a chopping knife. It just wasn't there. I really think it had a lot to do with the ergonomics of our pistol grip here. Secondly, the weight of the blade. It's pretty heavy. It's like using a hatchet for sure. But hey, the weight of the blade, it does its job. That's what it's there for, is to use that inertia. And I think that might also have had something to do with disallowing transfer of energy up my arm. But it just wasn't there. So super comfortable to use, and really happy with that. As far as adding extra power to the chop, I would have to go use it in a bunch of different scenarios to really ascertain whether or not that was the case. It certainly didn't hurt, I can tell you that much. So overall, I'm super happy with how it turned out. In future models or prototypes, my plan is to forge it down to something closer to a 1/4 inch or maybe 5/16. And just because that would make the tool a lot more feasible to carry, but also it would tell us a little bit more about how effective or useful this pistol grip design is for a tool like this. So that's kind of the plan. But overall I'm pretty excited about how it worked and the potential there. Another thing I thought of that I didn't demonstrate on video was the ability to use this as an improvised draw knife in something like a bushcraft situation or something like that. So that's another added benefit, I think, as well. Anyway, appreciate you guys watching as always, and we'll see you on the next video.